Dubai is currently creating more than 90 kilometers of beachfront on its newest island, but the older Palm already left a warning. Even while protected by a massive coastal shield, Palm Jumeirah later required a dedicated beach enhancement project. Approximately 1.5 million cubic meters of replacement marine sand were added to the older island. The developer explicitly stated this program was to restore beaches affected by natural erosion over time. Now, billions of dirhams in infrastructure and real estate are advancing behind a much larger artificial coastline at Palm Jebel Ali. The real question is not whether Dubai can build this land. The project clearly proves that the engineering is possible. The question is how Dubai can keep the sea from continually redesigning that edge. The first line of defense against this moving water is so large that most people simply mistake it for part of the island itself. Palm Jebel Ali is no longer just a future render waiting for approval. The project spans 7 distinct islands and 16 tightly packed fronds. It introduces approximately 120 kilometers of new coastline into the Arabian Gulf. More than 13 billion dirhams in construction and infrastructure contracts have already been awarded to bring the massive masterplan into physical reality. The first phased handovers of luxury villas are scheduled to begin from late 2026 and continue steadily through 2027. This rapid development timeline forces a fundamental shift in how the coastline must be treated. A moving beach is a completely manageable variable when it is surrounded by heavy dredging equipment and active construction crews. In a purely industrial zone, if the sand shifts, an engineering team simply brings in heavy machinery to push it back. But this environment becomes an entirely different class of responsibility once finished homes, public roads, and sensitive underground utilities sit right behind the sand. The boundary of the island has been clearly drawn on the master plan. But what keeps that exact boundary from continually moving in the physical world? Palm Jebel Ali is crowned by an enormous crescent-shaped breakwater. This structure is essentially coastal armor. It stands directly between the exposed open water of the Arabian Gulf and the carefully profiled beaches positioned safely behind it. Its primary engineering function is to aggressively reduce and dissipate incoming wave energy before it can impact the residential fronds. By breaking the raw force of the sea near the deep water perimeter, the breakwater creates calmer, highly controlled hydrodynamic conditions for the reclaimed coastline inside. When you look at the sheer volume of rock placed along that outer edge, the solution seems definitive. If you build enough heavy rock protection around the perimeter of an artificial island, you might easily assume the problem is permanently solved. Except Dubai's first Palm shows that the story absolutely does not end there. The beach enhancement project on Palm Jumeirah covered approximately 55 kilometers of beachfront. It involved the careful readjustment of both the beach width and the coastal slope to meet precise design specifications. It required the delivery and placement of roughly 1.5 million cubic meters of marine sand, but this significant engineering requirement did not mean the artificial island was structurally failing. The breakwater did not have to fail for the beach to keep changing shape. This is the central paradox of artificial coastlines. The rock shield can effectively reduce the amount of energy that reaches the sand, lowering the height of the waves and slowing the internal currents. It does not make a beach stop behaving like a beach. To someone standing on a luxury villa terrace, a beachfront looks like a fixed, permanent object made of solid ground. To a coastal engineer, that same beach is moving material that is continuously affected by localized waves and circulating water. Maintaining the desired shape of that sand is itself part of the ongoing engineering process. If this natural adjustment surfaced on the older Palm, the next question becomes highly relevant. What is happening on the new island before most residents have even arrived? The shoreline of Palm Jebel Ali is already functioning as a highly active, heavily engineered system. Recent operations by Jan de Nul demonstrate exactly how much precision intervention is required to shape this environment. Approximately 64 kilometers of the new shoreline have been accurately profiled. Silted material was actively removed from the coastal edges to ensure the correct foundation for the beaches. The edges were then aggressively replenished with new sand to establish a completely stable coastal strip. This precise profiling is followed by heavy ground improvement techniques to prepare the specific sites for actual villa construction. There is also a massive separate assignment involving the dredging of approximately 10 million cubic meters of sand. This specific volume is being used to widen the main trunk of the Palm by roughly 0.5 kilometers. These intensive works are not emergency repairs for lost land or evidence of runaway erosion. They are precise, calculated preparations to create the exact coastal edge the future community requires. The shoreline itself is simply one of the engineered systems of the project, requiring just as much attention as the road networks or the power grids. This level of shoreline management might seem relatively straightforward right now. Dubai obviously has the financial capital, the dredging fleets, and the top coastal engineers. Sand can be moved, rock can be inspected, and slopes can be adjusted whenever necessary. So why not simply maintain the coastline whenever the sea alters it? That assumption sounds incredibly simple, while the Palm remains an active, heavy construction site. A fleet of dredgers moving 10 million cubic meters of sand is standard procedure during the reclamation phase. But Palm Jebel Ali is rapidly transitioning from a construction zone into a permanent, high-end neighborhood. That single demographic shift changes the engineering stakes completely. As construction advances across the residential fronds, the environment directly behind the shoreline is fundamentally transforming. Before occupation, shoreline performance is strictly a technical construction issue. After occupation, shoreline performance becomes a long-term community responsibility. Behind this artificial coastline will increasingly sit private homes, landscaped gardens, public spaces, and sensitive underground utilities. The stakes shift from creating raw land to protecting highly valuable operational assets. The engineering challenge completely changes character. How do you efficiently manage a moving coastal system once it becomes someone's permanent? You cannot simply park heavy industrial dredging equipment outside luxury villas every time the beach profile shifts by a few meters. The logistics of moving sand become vastly more complicated when you are operating around occupied residential property. The sheer scale of Palm Jebel Ali makes this a massive logistical obligation. We are talking about 120 kilometers of total coastline. That includes more than 90 kilometers of dedicated beachfront. Every additional kilometer of engineered edge creates another boundary that must be thoroughly understood and continuously monitored. It must be managed according to the specific local hydrodynamic conditions of that exact spot. Water behaves very differently deep inside the tightly packed fronds than it does near the exposed openings of the outer crescent. Some stretches of sand will naturally accumulate material due to the specific angle of the currents. Other stretches will gradually narrow as wave energy pulls the finer grains away. Dubai has not only created massive new landmasses in the Gulf, it has created an enormous new interface between the land and the moving water. And this is exactly where the word construction becomes a highly misleading concept. The heavy lifting and the dramatic land reclamation will eventually reach completion. The tower cranes can leave the fronds. The luxury villas can be officially handed over to their owners. The road networks can open to daily residential traffic. The individual dredging and profiling contracts can safely conclude. But the sea does not finish its contract. The physical forces acting on the coast never clock out. The waves continue to arrive against the breakwater. The internal currents continue to circulate around the fronds. Storms continue to periodically pass through the region, temporarily altering water levels and wave energy. The coastal material naturally continues responding to those constant physical forces. Everything discussed so far assumes that engineers are merely defending the coastline against a known, fixed set of design conditions. But Palm Jebel Ali is a flagship community expected to exist for generations. And over long periods of time, the environmental conditions themselves can fundamentally change. The first antagonist in this engineering battle was the sea. The second is time. Every piece of coastal protection infrastructure is mathematically designed around a specific set of expected environmental conditions. Engineers calculate anticipated wave heights, tidal water levels, regional storm frequencies, and specific structural criteria. These calculations establish a defined design life for the breakwater and the beaches. But the Arabian Gulf is a dynamic body of water, and those base design conditions are not frozen in place forever. This introduces long-term environmental uncertainty into the ongoing management of the project. A peer-reviewed coastal study examining the rock revetment on Palm Jumeirah illustrates exactly how engineers must think about this shifting baseline. The researchers specifically considered future sea level rise scenarios. They explored possible structural upgrades intended to safely extend the design life of the existing coastal defenses against these changing conditions. The study proposed several conceptual future adaptations. These included the placement of additional heavy rock armor to increase the height of the defense. It also discussed the construction of new protective berms, or the integration of offshore submerged breakwater solutions to break wave energy further out at sea. This academic modeling is not evidence that the older island is currently failing or washing away. It is evidence of how long-term coastal engineering actually works. A massive physical defense built for one specific set of baseline conditions may eventually need to be actively adapted for another. Time forces the engineers to constantly evaluate whether the original shield is still sufficient. To understand why this adaptation is possible, we have to look closely at how the breakwater actually functions. It is not a solid, impermeable magic wall that simply blocks the ocean like a concrete dam. A modern breakwater is a complex, permeable structure built from carefully graded layers of rock armor and core materials. When heavy waves strike the outer face, the water does not simply bounce off. The gaps between the massive outer rocks force the water to violently break and disperse its energy within the structure itself. This internal turbulence converts the kinetic energy of the wave into harmless motion and sound. The engineers also factor in acceptable levels of wave overtopping during severe storm events, knowing that some water will occasionally clear the crest. Because it is constructed from individual rock units rather than a single poured concrete monolith, the breakwater can actually be maintained, upgraded, or modified over time. Rocks that naturally settle or shift under decades of constant wave pounding can be systematically inspected and replaced. The entire profile can theoretically be heightened or thickened if future environmental conditions demand it. The most important technical takeaway is that coastal protection does not completely eliminate water movement. It actively manages that movement. The breakwater is simply the most visible, aggressive component of a much wider coastal management system. And to see the most sensitive part of that system, we have to look past the rock armor and return to the sand. This brings us back to the reality of beach nourishment. The earlier beach enhancement program on Palm Jumeirah serves as a perfect case study for the newer, larger project. It proves that even behind a massive, highly effective breakwater, a managed artificial beach can eventually require extensive reprofiling. It requires strategic sand placement, continuous topographic monitoring, and localized physical adjustments to maintain its design. As waves and internal currents naturally redistribute the placed marine sand, they can gradually narrow certain stretches of the coastline while widening others. This sediment transport means the coastal edge is never completely static. If the sand itself can require periodic renewal and heavy mechanical intervention, it forces a completely different perspective on the master plan. What does it really mean to say an artificial island is finally finished? The property developer can successfully sell every available plot. The construction contractors can demobilize their dredging fleets and leave the site. The residents can move into their homes and park their cars in the driveways. But the precise coastal equilibrium required to keep those luxury properties safe, accessible, and visually appealing is not a fixed state. It is a fragile physical condition that must be continually enforced by human engineering. This requirement reveals the true hidden obligation of building cities directly into the sea. The underlying structural difference here is the massive gap between the concept of building and the reality of coastal management. Constructing a luxury residential tower or a major highway network is a project that eventually reaches a definitive completion date. Once the structural concrete cures and the final asphalt is laid, the primary engineering effort is over, leaving only standard facility maintenance. But managing a complex artificial coastline is an active process that continues for as long as the desired coastal condition actually matters. There is no final handover date for the hydrodynamic forces of the Arabian Gulf. The long-term operational obligation to defend that specific boundary does not disappear simply because the real estate has been sold to residents. Every single meter of that 120-kilometer shoreline will require observation, periodic assessment, and potentially active intervention across the coming decades. The real engineering achievement of Palm Jebel Ali is not simply dredging the sand and creating the massive landmass. It is continuing to preserve the exact physical conditions that make that land usable, year after year, against a force that never stops moving. This is the hidden cost of permanence. The massive scale of Palm Jebel Ali might make it seem like Dubai is simply repeating an enormous coastal experiment. But the construction of this second island does not begin blind. The ongoing management of Palm Jumeirah provides engineers with over 2 decades of incredibly specific real-world data. They now possess long-term operational metrics on breakwater performance and internal wave modeling. They know exactly how fast sediment transports around artificial residential fronds. They understand the precise logistical requirements of continuous shoreline monitoring and mechanical beach nourishment within the Arabian Gulf. This accumulated engineering experience drastically reduces the environmental uncertainty for the new project. But while experience optimizes the coastal defense strategy, experience does not abolish the sea. The ultimate lesson from Dubai's first Palm is not that artificial islands cannot work or are doomed to fail. The lesson is that structural success itself is a condition that requires continuing human intervention. Better hydrodynamic data simply allows coastal engineers to predict the movement of the sand with much greater accuracy. It allows them to confidently schedule the necessary dredging equipment before the local beaches narrow past an acceptable limit. It ensures that active coastal management is fundamentally built into the project from the very beginning, rather than being treated as an unexpected emergency response. But the core requirement to physically intervene and maintain that coastal edge remains exactly the same. If these physical forces never stop acting on the artificial coastline, it forces a highly provocative question. Can the sea actually win this long-term battle? The answer requires a nuanced understanding of how modern coastal engineering actually defines failure. The sea winning does not mean that Palm Jebel Ali will eventually disappear beneath the surface of the Gulf. It does not mean that completed luxury villas are suddenly going to wash away during a storm. It certainly does not mean the entire structural foundation of the island is going to catastrophically collapse. Those are cinematic scenarios that completely ignore the heavy physical reality of the breakwater and the ground improvement works. In the context of a highly managed artificial island, a loss looks entirely different. A realistic loss means severe beach narrowing that degrades the waterfront experience for the residents. It means continuous natural erosion eventually forces the community into a cycle of repeated, highly expensive sand nourishment. It means the existing coastal protection might eventually require heavier rock armor or structural upgrades to handle changing environmental conditions. The real threat is not sudden destruction, but rather a continually rising operational burden. The battle between the new island and the water is not a binary contest of survival versus collapse. Success simply means keeping the physical conditions of the shoreline strictly within the exact range that the human community requires. Palm Jebel Ali is rapidly positioning itself to become one of Dubai's most important and expansive waterfront communities. The massive masterplan will eventually cross the final finish line of its primary construction phase. The thousands of luxury homes will be completed. The public road networks will fully open to daily traffic. The heavy dredging crews and construction contractors will finally pack up their equipment and leave the site. But the physical hydrodynamic forces acting on the outer crescent and the internal fronds will continue exactly as before. The true engineering accomplishment of this massive project is not defeating nature once to create the initial landmass. The real accomplishment is proving that specialized technical intervention can continually manage a boundary that nature never stops acting upon. It is the commitment to a permanent process of observation, adaptation, and physical reinforcement. Dubai clearly has the capital, the vision, and the engineering capability to draw a definitive line on the map. It can decide exactly where it wants the new shoreline to exist. The sea will simply keep testing that decision, wave after wave, for generations to come. This video is created for educational and analytical purposes, relying on currently available project data, coastal engineering principles, and public records. Long-term environmental models and future infrastructure requirements are subject to change over time. This content does not constitute professional engineering, architectural, or real estate investment advice. How do you think artificial coastlines will adapt to changing environmental conditions over the next few decades? Share your perspective in the comments below, and subscribe for more deep dives into the hidden engineering systems shaping our cities.